Kyle Denman, head of engineering, founder as well of Boxabl. We were here a couple years ago before the manufacturing line was even open. You guys were just getting set up. Kyle, why don't you give everybody just a quick background on who you are and how you actually got into doing what you're doing here at Boxabl?
Sure. So the director of engineering at Boxabl. So I lead all the product design.
Yeah.
So I've been involved in the project since the beginning. Basically 2016, 2017. 2016 I started working for Apollo, actually on a different project. And then Boxabl started to get really big, so it took over more of the time, and then I started to lead all in for design stuff from there. So I've been heavily involved in product design, the actual manufacturing line, and then luckily now we have an actual manufacturing engineers that have taken that over for me because they know much better than I do about how to set up a line. But it's been a wild few years.
Let's talk about the lines a little bit. And I know we've had this conversation in the past, and there's been a lot of YouTubers and other people through here that actually talk about this is the process. But for our audience, going from conceptual design of what this could be to prototyping to building a very manual line to begin with, and like you just said, now you're looking at more automation and really ramping up. Walk us through what that process was like, because you were carrying, I would imagine it was just the three of you, Paolo, Galliano, and yourself. You were probably carrying most of that load on your shoulders for the beginning of this.
Quite a lot of the design stuff, yeah. I mean, just frankly because we're busy, right? I mean, just the three of us is, lots to do. So I ended up tackling, most of the 3D modeling, the design, the engineering, the drawings, getting stuff made. Luckily now we have a much bigger team, across design and manufacturing. We have, 8-9 guys. So it's been really helpful to kind of be able to take a step back at the current product design and look and work through all of the issues from a design, forward perspective. So when we developed this generation of product, we were on a huge time crunch. We only had like 4 or 5 months to completely design it from scratch to finish, as well as the facility that was going to build it.
Because of the order that came in.
Because of the order.
And they had a timeline and a deadline for you.
Exactly. So we just didn't have a lot of time, and we only had, towards the end of it, maybe a dozen people.
Right.
So we went from, like 3 people to like a dozen people in maybe a year, and about that same amount of time to do the entire development. So it's just not enough manpower. So we got up and running. We're making the product. The product is performing. But we're really excited for this next generation coming out because it's going to solve a lot of the issues. I mean, a folding house is quite difficult.
Yeah, for sure.
So at the end of the day, walls, floors, roofs have to seal. Things have to work in the field without leaks and stuff like that. And it's, it hasn't really been done to this level and this scale before.
Yeah.
So there was a lot of like little nuances that had to get fixed, and they were like holistic issues which we didn't know about from the beginning, right? Like, are we going to have issues with the I-beam slightly flexing where they meet the floors and roofs as the thing unfolds?
Sure.
So we weren't sure if that was going to be an issue or not. It's a minor issue, but what it does is it causes like a drywall crack in the ceiling.
Yeah, sure.
So like in the field, there's like little field repair stuff. So being able to like recognize all those issues and then also recognize the issues the manufacturing guys have, whether like, oh look, if we designed it, this way, or if I could just hook the cabinets on or something, it would cut 40 minutes off this station, it would cut 30 minutes off here, and now instead of making a house every 4 hours, we can make a house every 40 minutes. So that's been the goal. So that's been like the last year in the design team's focus is working on this whole new generation. Whole new material, new process, new way of building. The entire thing's completely different. And it's all taken from what we've learned from this past 18 months of actually manufacturing, something that had never been manufactured before.
Right, and the factory opened, it wasn't even 2 years ago, right? When you started running down?
Maybe 20 months, but like the first 2 months were pretty rough.
Well, with our experience and how this all comes about, because there's other companies as well around the world that are, prototyping and trying new ways of building, not to the extent that you guys are doing it. But I would imagine just the design of the hinge, how do you stay within 8 feet? And even yesterday when they unfolded and you could see all the packaging, you're also taking into consideration how do you get the refrigerator, the dishwasher, or, not the dishwasher, well, I guess, you got the refrigerator, you got the stove, and you got the washing machine. How do you get all that in there while shipping it down the road? So we talk about the first iteration, and I know you can't share everything, there's some IP, but as you're looking at your lines now, they're very manual, and like you said, you've hired people smarter than you, which is the smart thing to do in this industry, because there are people from the automotive industry and other industries that understand product, through a production line. DFMA, I was talking to Pilot yesterday, I didn't hear that before. So DFMA, Design for Manufacturer Assembly, and now they're doing DFMAD, right, and disassembly, which you can do with your homes.
Yeah.
What's the difference between the first iteration and what you're looking at now moving forward?
Well, literally that, right? I mean, so we are doing DFMEA and stuff like that, DFEMAs and PFEMAs on the actual product.
Yeah.
Before we start making it this time.
Right.
And it was, again, I wouldn't change anything. We had this timeline.
Yeah.
It was great. It got everything up and going. It worked out phenomenally
Sure.
at the end. But realistically, we needed another year to develop the product before it was ready for a production line, which is what we're doing with this next generation. And there's also like some major changes to how we're going about designing and building the buildings. I can share a bit of this conceptually. Basically right now, when we build a panel, the parts that go into that panel are predetermined.
Okay.
Meaning if this panel is going to end up with a window and a door and 3 receptacles, all of those parts are pre-configured with all of those features before they hit the assembly line. What that means is to build the panels that build the house, it's about 900 individual part numbers, and that's just for the vestibule. So if we start doing different floor plans, that number explodes. So the next generation what we're doing is we're building more of a universal panel and cutting it to shape afterwards. It gives us 2 things. One, it gets the SKU count from, I think it's around 600-700 to like 60 that go into building the panel, which logistically makes everything run much smoother.
Sure.
And the other thing it does, because we're cutting it afterwards, and we can do this in a little bit more of an automated way, our accuracy goes through the roof on those panels. So that has a trickle effect when we go to build the houses. The more square and perfect your walls and floors and roofs are together, the more perfect the house is going to be.
Sure.
Which means the better it's going to seal, the better it's going to unfold, the better it's going to perform out in the actual real world. So that's like a huge change that we're working on now that's going to pay huge dividends down the road, is the actual infrastructure of the home is going to get changed quite significantly.
From a production standpoint, standardizing those components and lowering the SKUs is also going to help simplify and make the data for the automation go much quicker and much smoother in the assembly line process as well.
Yeah, exactly.
Yeah. So this new iteration, is it something that's in the works now, or when does this start taking effect?
So we started building some testing stuff the past few months. I'm hoping that we get through our panel testing with this next generation by hopefully around August or so this year. It's a pretty aggressive timeline, but we've been doing a lot of R&D on this for a while now. We've been doing a lot more meetings with the design and the manufacturing team, which is something that Musk talks about a lot. There's no reason for those 2 groups to be separate. I can't design something that can't be manufactured, and vice versa, right? If they have input on, how we should go about flying these walls to get them assembled better, and there's something I can do that's really simple on a design set of things to make that happen, why should I not do that? It just all pays dividends. So we're doing a lot more reviews about the design and the manufacturing of the product. So that's going to be ongoing for the next probably 6-8 months, with a hopeful launch in probably September, October, realistically.
Yeah, September, October. So the design, what are your biggest challenges? The whole thing's a challenge. I understand that, right? But when you think about starting this, I mean, there's some excitement in between, well, we don't really have it figured out yet, we're just going to start building. And then that's where the IP comes in, and you start figuring out hinge plates and connection points and all of that, and the system rolling across the roof and so forth. What is your biggest challenge day to day?
I mean, on the design side of things, I would say the biggest challenge for us is like sealing stuff,
right?
Making so that it actually performs well. What I'm trying, like the biggest goal for the design team is to get this product to be something that's a consumer grade good.
Right.
Which means you don't have to have specialized skills or tools or knowledge to be assembling these things in the field. So there's a lot that goes with that, right? I mean, everything has to work almost like semi-automatically or like really, really easy. It's like easy as you possibly make it. It's got to go together. I mean, simpler than IKEA furniture. For actually building this.
It needs to be simpler than IKEA. I don't find IKEA furniture that simple.
No, I don't either.
I don't know if it's just me, but that one tool idea, you know, they need better directions, I guess.
Yeah, exactly. But yeah, that's probably the biggest challenge of the engineering team is making everything work really, really simply and really robustly so they work forever. And then probably the next biggest challenge after that, if you have something that works and works well, is making it work and work well for every different type of application. So the casita is great. We don't want to be making casitas forever, right? We want to build much larger units, and we want to start stacking, connecting units to build much larger buildings. Right. That's where the product really takes off. I love the casita, cute little house. It's a tiny, tiny, tiny percentage of the housing market would be casitas, right? Single family homes, apartment complexes, those are much, much larger, shares of the market. So as soon as we get to, we can build 20 by 40 foot modules and put 2 or 3 together and end up with 1,500 to 2,100 square foot single family homes. It starts, I think, to make a lot more business sense at that point. And then, so the challenge there are utility connections between modules. So
wiring harnesses.
Wiring harnesses we're working on. It's difficult with high voltage electricity. So, for example, if you've got, a range and like a tankless water heater, that's like 6.3 Romex. There isn't a connector out there right now that is rated to do that. So there's about stuff like that we have to kind of figure out. To not have to be snaking wires through houses. But
low voltage is the future, and I know you guys are looking at some of these low voltage designs. I mean, all the lights are LEDs. There's only a few things in a house that need something more than low voltage wiring, and
the main things at the moment would be really the water heater and the range are the only two like high voltage.
Microwave, I would
the microwave, but even then the microwave is only 10 too, so we actually have connectors for that. Those are the tough ones.
For sure. Hey, I have a guy that's using solar power, and he's building on site with all solar, running all of his equipment and machines. I'll have to connect you guys, which is great. All right, so we talked about the challenges. I would imagine there's several of them, not just even on the design side, but the growth side, building the team. You showed the next generation of multi-dimensional builds at the International Builder Show, so it got a lot of press, right? That was 3 of your Boxables together. What were the challenges on that?
That one actually was pretty easy. So we just took 3 casitas and we just made a couple of floor plan modifications. But the thing is, we did it all manually. Right. So we built 3 casitas, then we put them on our parking lot, and then we had our install crew go through and modify them. Which is not great. I mean, it took several months of modifying, tailoring them, getting them to work, and then at the end of the day, like the bathroom, like the plumbing wasn't necessarily set up for the units, right? It needs a lot more thought to figure all that stuff out, so it actually just kind of connects and works. That one for the show wasn't too difficult. If we go to do that in reality, there's still significant work to do.
Right, to pull it together for sure. Walk me through the new lines. Can you give us kind of an idea? We did with the Fabs, had a great time. It wasn't Dave walking the lines, talking shop. I let Luis, the Fab, do it for us, and he did a great job. But just so you know, everybody here has been amazing to deal with. And we've been staying in the casitas down here, and they're not that small. When you're in them, I know it's a 1-bedroom, like studio almost setup, but it has been very comfortable. So if you want some real feedback on that, I'm more than happy to give it to you. So we've been happy with that. The production line itself, though, it's still fairly manual all the way down. Where are you going with it?
Sure. So, as I mentioned before, so we build the panels, and the panels build the houses. We use the panels to build the houses. So there's 2 parts to the production line. One is going to be the panel building line. So right now it's very manual. The guys, they assemble parts by hand.
Press it.
It gets glue is automated, more or less. But then they, keep stacking up, building this layer cake, kind of help manually push it into a press. The next generation line, effectively, there's 3 layers, right? There's the outside skin, the foam core, and the inside skin. They're loaded manually, but then conveyored and collected and corralled with robotics. Then the robotics pick up and hover in like what we're calling like a pounce position. These layers over top of each other while they're getting glued. So what it means is that those skins now are perfect, right? They're corralled into stops and stuff like that, pressed together. And we can go from a 30-minute glue time to a 3-minute glue time. Because basically, we don't start gluing until all the panels are ready. Glue, put down, go into the press automatically. Now, totally automatic controls, and then press for a couple minutes. So what it means is we go from a total panel cycle time of like 2 hours.
Yeah.
Right now it's like a half hour when you apply the glue and like an hour and a half to put under pressure. But if you can go down to 3 minutes to apply the glue, you can go down to like 4 minutes to apply the pressure. So now we go to like 7 minutes. Right, so now we can make a panel every 7 minutes.
Yeah.
Instead of every 2 hours. And that panel is going to be way more accurate than we're doing today. Right now our panels can float a 1/4 inch all around.
Yeah.
Which in construction terms is not a lot, but in automotive manufacturing it's an inch. Right, so when we're getting ready for robots later that move these panels to connect them together, robots can't really handle a 1/4 inch. They can, they just get very expensive. So that's part of it. Panels are automatically built, and then they're CNC'd now.
Yeah.
Cut out windows and doors and outlets and stuff like that. So that's much more accurate than even what we're doing today, where the parts are pre-cut and then they kind of shift as they get glued and stuff like that. Even if they shift a little bit, it still throws things out of whack. And then they're automatically conveyored up and put on an automated paint line.
Yeah.
Right? So it's still semi-automated. It's a conveyored paint line. Panels move through a conveyor system through a series of booths. They're going to be manually sprayed, but through an automatic system. So it's going to be very accurate.
Right.
And then, so when the panels come off of that line, they get fed into our actual assembly line. So we're getting in a big boy real assembly line with carts. So the houses are actually built on these carts and
Conveyor belt them.
Conveyed.
Yeah, sure.
Yeah, and then we're working on, okay, well, if we're doing this, what are the areas that are exactly the same every time that we can do robotics for? Ideally building out the core, because the core is going to be the same no matter what configuration it is, no matter what. It's always those same, 3 exterior walls and floor and roof. So if those are the same forever, then let's make them perfect. If we're going to make them perfect, let's get some robotics in. So that's kind of the next step. Everything until that step is purchased and is coming in.
Yeah.
Right, it's been developed, it's been bought, paid for, and it's all coming in.
Yeah.
And that stuff is probably all going to land, hopefully, through June to August. It's like a big window for all that stuff to come in. There's obviously a lot of shuffling around we have to do to shut stuff down.
And that's all going to be in the main plant?
That's all going to be right here.
Right here, yeah. And is it something that you're going to be able to plug and play as you're still moving production down the line?
Yeah, so basically there's like enough room here to build the panel line, do a bunch of testing and run through without even affecting the current production line at all.
Yeah.
And then as we're comfortable with that, we can kind of take away half this line, because half of this is the panel line.
Yep.
Put in half that conveyor line, start building on the new conveyor line, test that out, and then take down the old assembly line and extend the conveyor line. So
even further,
We'll do it in tranches.
Yeah. Well, it makes the most sense, right? Because you still got to get the orders out the door. You can't shut down production. This has been an industry thing for a long time with, factories trying to improve. What is the best way to do it, without losing production time that you already started.
That and it's so new and unproven.
Yeah.
All of this stuff is new. The design is new. The materials are new. We can't build the same way we're building today on this line. So we can't afford to just this month we're shutting everything down and figure this out. It makes more sense for us to take our time with it. Yeah. We'll pull off some engineers and maybe a couple operators to make sure that the new line is working like we said it is, work out all the little kinks while this line is working. It makes more sense to me. It does make more sense. And, I want to go back to something you said, 1/4 inch tolerances in the construction industry. Well, I don't think there should be that either. I mean, on site, I get it, but not in a factory environment. Not when you're using a hinge system, I don't know what it was, but it was like a triple lock, hinge. And you can't even be probably 1/8 of an inch out on something like that. It has to be down to the millimeters. Yes, a 16th is our normal accuracy moving forward. 16th across 20 feet is a pretty significant tolerance. Even on a large CNC machine. Right. So, but yeah, that's about where we're going. We're going to try to tighten it up from there, but it does mean that all the components going in need to be 10,000ths accurate. Right. You get tolerance stack build up. 6 components, 10,000ths accuracy. You're at a 1/16 of an inch. Tell me the design process. Are you guys, what are you guys currently using for your design software? Well, the same thing we've always been using. I use SolidWorks. Yep. So I'm a 3D modeling guy. I've done some AutoCAD work. I used to work as a civil engineer very briefly back in New York, doing some layout stuff. But we have a 3D structure that folds and connects and is really, really complicated. I'm not just putting studs 16 inches on center, so I need something much more robust to do that design work. It's SolidWorks I'm very familiar with. So the other nice thing about it too is we can use simulation and stuff like that. So basically, started doing a lot of the new components. There's a lot more like injection molded components, a lot more cast components, a lot more high automotive type manufacturing materials going to this next generation, and they require a lot of testing. So it's great. We got simulation. We can apply loads to stuff in 3D modeling and make sure nothing's going to break. Make sure it's got plenty of factor safety before it comes in and we test it physically. So it saves a lot of time in design and doing stuff like that.
So, go ahead. Did I cut you off?
No, that's
somebody going on a computer, right? And this is more of a question of whether you're going to do that as well. Where will somebody be able to input what they want to order in the computer? It comes into your design team, and then your design team and your software can spit that data straight to the robotic line all the way through production? The
ultimate goal is that the design team develops every possible situation, and then those configurations are dumped into a configurator.
Yep.
That configurator has a set of rules. Like, if you put a window here, you cannot have an outlet here. If you put a door there,
if this, then that.
If this, then that. So we'll set up all those rules. There's plenty of configurators out there. It's not really that complicated to do. We even actually basically already have the rules set, because part of the development has been our grid system, where you can put windows, where you can put doors, where you can put electrical, all that stuff. Basically, we have structural load paths and utility load paths, and they're on a standardized system like Lego bricks.
Yeah.
Right. So we've kind of future-proofed ourselves to do whatever we want. A door becomes a hallway, a window becomes a hallway, windows become doors.
Right.
That all is pretty easy. Where kitchens and baths are, those could be stairways and closets and stuff like that. So, yeah, once we establish all of those different configurations, you'll be able to go online, like you kind of can do in a car configurator.
Yep.
And say, yeah, I want the 2-door versus the 4-door. Right, I want the short bed, I want the long bed. We'll be able to go, okay, I'm going to start out with a 20 by 20. And I want a studio layout, or I want a master bedroom layout, and then I want another module that's a kitchen bath layout. So they'll have a hallway between them. And it should set up all those rules for you. That's a pretty big software project.
It is.
We got started on it a few months ago, so we're very early days. That's going to take probably years to develop before it's like ready to go, and like you'll be able to go to Boxabl.com and build out your house.
I equate, coming up with something like that, like winning the lottery. When you think about, just the numbers you can pick for a lottery and how billions of people can buy a lottery ticket and nobody wins, it's the same thing with the house, that things can be moved and configured. And, obviously that's a bigger viewpoint on it than most, but with so many pieces and parts in a home, everything, you move one thing, everything else changes.
I think that one of Ford's vans has 27 million configurations.
See, that wasn't wrong then.
And it's just the van. It's not like it could also be a pickup truck.
Yeah.
We could be a studio, and we can also be like a single family. So it'll get pretty intense.
We were talking about a little bit yesterday on the show too. Is the car manufacturers, they have, I'm making it up, but they have like 20 chassis or 10 chassis, and it can make 300 vehicles. Whether it's trucks, cars, and that's the same thing. To scale, that's how they do it. But you can go to pretty much any auto manufacturer and find something that you like or will work for you. And that's really kind of the concept you're taking here, is you're developing the chassis of these buildings that can be expanded upon, and hopefully you don't have 90 million configurations or whatever, but
hopefully not. Yeah, we're building the infrastructure now.
Yeah.
So that's like I said, one of the other big challenges is building that infrastructure so it's modular and scalable to hopefully every use case we can possibly come up with.
AR, VR. It's a hot topic. It's coming. ChatGPT and all this other stuff that's out there. How's that fitting into the forward-looking?
No, it's not doesn't play a huge role for us at the moment.
Yeah.
We have some AR and some VR stuff set up. We used to kind of walk through the houses virtually and stuff like that. We're in like Oculus or whatever. As we start to build out that configurator, it'll take a bigger role, because it will be a sales tool. Right? I mean, you'll be able to go, okay, this is how I've configured my house. Now can I go walk around it?
Yeah.
Right, so it'll be built in to that configurator system. We have some, like I said, we've been playing around with it for a while ourselves, and we'll keep integrating it into that system for sure.
What are you most excited about, Kyle?
I'm pretty excited for this new line. I want to see these things go down and work. Like, I like the way they're working today. They work okay, but I'm excited to see these things really work.
Yeah.
Like, I don't care if the foundation is level. We don't care how badly whatever contractor's site. These things just get installed. They're done. They're waterproof. They're they're good to go. I'll sleep a lot better at night when the product is like
solid.
functioning in every use case.
For sure. So with a foundation system, if it is not level, like what will you do? Because you have to be somewhat level with these things. You cannot be out of level.
No, I mean, this is the problem actually we have right now is you have a folding floor and then 2 folding walls.
Right, and the walls get hooked on the floor if it's out of whack.
If the floor is slightly out of whack, the walls won't even unfold.
That's right.
So basically I'm incorporating that into the next generation design. So the next generation design, the walls actually float above the floor with like a 1/2 inch gap. So it does 2 things for us. It's going to allow us to do different flooring in the final at some point, which I really kind of want to get away from. It's just because it's, it scratches and dents quite easily. So for a folding house where you have to move stuff around, it's just not so great. But the other thing it allows us to do is have much more tolerance in the foundation things. The other thing we're doing is like the interlocking and the gasketing system. The way that's working, the way that we're actually able to cinch up the panels in the next generation, we're going to take a lot of that tolerance out of it. So, if you had, God forbid, a 1/4 inch gap because the foundation was so out of whack, the house should still work perfectly fine.
Sure.
That was the other goal. Was that like, okay, conditions on site don't have to be perfect to make this work.
Right.
They never will be. But also, I want them to be doing less shimming.
Sure.
Because the short answer is neoprene shims at the moment. That's the way you handle that now.
Yeah, well, I'm a firm believer for contractors and masons. If you're a master at your trade, why can't it be flat and level? And then I get argued all the time, and I say, well, let's go to some churches over in Europe. Without all the tools and the accuracy and even the pyramids. So, but a labor force, right? That's the problem, really, is having a labor force out there, younger generation that wants to take up these trades. And so I know the struggle and what's going on with that. Well, this is exciting. I'm super excited for you guys. I have to tell you, this new robotics line's got to be. You went from concept, now you got it, right? And now you're into. Now we get to really fine tune a line. So I could see how that probably gets you excited to really start putting it back together again. It's just another project for you. Being an engineer, you guys like projects, right?
Yeah, I like solving problems.
All right, cool. All right, so where are we at with everything? So I got the whole team back here. You can wave to them all. We've been live now here for 24 hours. So you fixing his mic? Yeah. Well, listen, Kyle, I think this is awesome. We're really looking forward to being here tonight with you guys as well. We got a bunch of other factory owners, CEOs, and execs from around the world coming in. Hopefully all their flights are on time and those things. But it's really important that you and also all these other people that we have coming in communicate and talk. Because I think there's just so much to learn from each other. There's innovative systems all the way around. You're focused on the single family market at the moment, right? ADUs, affordability, and so are some of the others. They just have a different widget and how they're going about doing it. Nobody has done the transportation thing.
Yeah.
That's the key.
Yeah, that's the key for us. And we've got a couple of different things we're figuring out now on that side of things, which I'm excited for.
Right.
A couple of different types of trailering systems.
Sure.
For delivery trailering systems to permanent trailering systems.
Right.
To scaled large trailering systems with like pickup truck vehicles instead of big rigs. So that's been a huge focus as well. I mean, obviously we're still a pretty small design team, but like a third of us right now, that's like a big focus of ours.
Did you also design the trailer, or did you work with somebody to come up with the trailer concept for this?
Mostly Paulo and one of our other engineers, Cody, have been working on that design. I have input on it, but that's not my main focus. Is on the actual house, just because there's so much to do.
Right.
So.
Perfect. Well, I think we're getting ready to wrap up here in just a second as well. Do we want to take a question on LinkedIn? Yeah, you have. Oh, you sent it to me? Let me see. I don't see it if it's on here. Send it to me. Yeah, we'll take a question on LinkedIn. We're mobile, everybody, so I hope that signal's coming through really well. It should be in high definition. We've upped our game quite a bit, since the last time we were here traveling with our kids. There's a lot of questions that have been coming through. Obviously, I'm sure you see it all the time. While we're waiting for those to come through from Jen, what is it like to go from being an engineer to being somebody that engineered something that 170,000 plus people have put a purchase order down?
Yeah, it's interesting. Yeah, I mean, well, actually, what it means is my day-to-day goes a little bit less from designing widgets in my own little space to being like a much more broad, like a lot of admin type stuff and fielding questions and setting up and explanation, stuff like that.
Sure.
The biggest difference I would say, is going from just quietly plugging away on SolidWorks to like this broad,
scale of everybody in the world's interested in what you're doing. Yeah. I can imagine. I'm going to log in here.
It's also been great to develop the product too, though, because there's plenty of questions like, well, what do you do about plumbing between units? It's like, okay, well, that's been on the radar, but now I have to have an answer for that. So now I have to figure it out.
Right, for sure.
So there's been a lot of stuff like that.
All right, let me go in here. Ben Hershey, Forward Solutions Group. Is the seed of growth, let's see, innovation is the seed of growth, and growth is the fruit of innovation. Embrace the unknown, nurture your ideas, and cultivate a continuous improvement mindset. That is the path to lasting success, he says, and then he goes on, let me see here. What are you using for ERP and MRP systems?
We've got a couple of different ones. So the ERP system, we use NetSuite. And then the MES system, we're actually going to use Tulip.
Okay.
And then we are using Oracle PLM for a lot of the design stuff. And they all kind of integrate together. So basically the designs start in SolidWorks. They're hosted in EPDM. So all the acronyms sound exactly the same, which is not confusing or anything.
Right.
So those designs, once they're fleshed out, they go through PLM, they go through a change review process, we get sign off, we get buy off, we make sure that purchasing is aware of everything, we make sure manufacturing is aware of everything if they have to update, work orders, and then once that's all signed off, those new upgraded bills of materials structures, they get uploaded into NetSuite. So NetSuite knows, okay, well now when we're building a casita, it's got these components. And then Tulip, the MES system, says, okay, now based on the bill of materials from NetSuite, we need to pull these components to build this product. So it's quite a complicated system. We've been working on it for about a year and a half to get all that stuff developed, mostly in NetSuite. I'd say we're in Oracle PLM for the last 6 months and Tulip for the last 4. They're all going to go live within the next few months. Sections of it is live at the moment.
Okay.
So the warehouse management with NetSuite is live. The PLM is going to go live in May, and then I think Tulip goes live in June. Right now it's live in a limited capacity. So
have you, you're kind of like plugging a bunch of systems together to come up with something that works for you. Is that something you guys have been on the lookout for? Like, I think everybody's looking for a good ERP system out there that can go end to end, right? Would it make sense, and is it possible on a production line such as yours?
So it is. It's just a different configurability, right? So like the Tulip, we think makes more sense for the way we're going to be producing to use as the production tool.
Right.
What we would have to reconfigure from a NetSuite or like any Oracle-based system to get that functionality would be huge.
Okay.
So we did look at a series of different tools to do a couple of different things. Luckily, they all basically speak the same language, so it's not really that difficult to tie one to the other at the end of the day.
It's a big undertask.
So there's a lot going on.
Yeah, there is a lot going on, and I probably could dive into this for forever and a day. Is there anything that you want to share with everybody out there? And I say this because we get the questions coming through last night. I'm not going to answer them. You get the comments. Are they waterproof? Can they be waterproof? Can they survive hurricanes in Florida? How do you answer? Is it just yes across the board?
Yeah. Well, first of all, it's the goal across the board, like no matter what. And then secondly, we do really intensive testing on these, third-party testing, not just ourselves. So, we do these extended E331 tests where we build these Frankenstein panels with windows and connections and every type of roof and floor and wall to wall. They get sent out, they pull a vacuum on one side of this wall panel and they spray it with water for 2 hours and not a single drop can go through.
Yeah.
Like we do some really, really intensive testing on these things. But the problem is, that's like in an ideal state.
Yeah.
Right. So we've got in we've purchased some of that testing equipment.
Sure.
To build into our line.
Okay.
I want to test modules when they come off the line.
Right.
Probably not every one, but one every 50 maybe.
Sure.
Let's say we'll pull out and do this intensive test, make sure we're good, stuff like that. So a lot of that stuff it's just time, right? We haven't had the time to develop that into the process.
Yeah.
And it's one of our major concerns, so we are putting it into the process now.
Right.
On the hurricane stuff, I'm not. That's walls you could drive a semi truck over. I mean, I'm not
yeah.
even concerned about that. We have like a 200 and something mile an hour ultimate wind load. Miami is 170, Miami-Dade, but I think that they're actually changing it because they've had such high wind speeds the latest few hurricanes. But that's with our current generation product. The next generation product, our internal testing showed strengths of at least twice the current product. And we're talking about like really indestructible panels.
Yeah.
So that's going to go out for formal testing, hopefully within the next few months.
Yep.
And then we'll go from there. The other thing we're doing is we're testing. When we do that test now, we're actually going to do it with a section of wall, floor, and roof with our actual fasteners we're using, connections, tie downs, everything. So it's much more real world.
Yeah.
So basically we can all be a lot more confident about the actual result.
Sure. Last night, you guys were all shut down and we were still doing our live stream. I was on with a company called Vigo in Honduras. And Gilbert Meyer was a ballistic expert, bulletproof walls and all of that. And they've come up with a panel system, not a folding house, more of a flat pack shipping type thing. You should probably connect with him and see what they're doing, because I think he was saying they can get 30-foot clear load spans with no structure.
Wow.
And they're lightweight panels. So this is what I talk about, right? There's things out there. Everybody's reinventing, but I think there's a lot of people that have great products that should be talking, and maybe that's one of them for you. So they were saying they're going to pull one of the trucks up out front. Okay. So we can talk about the transportation, we can talk about the weight loads. Those trailers that you have, what can they carry weight load wise?
The ones we have at the moment are good for, I think, like 16,000 pounds, something like that, of payload.
And the Casita weighs what?
The current Casita weighs around 13,000 pounds, a little less.
A little less.
Next generation is probably going to be slightly heavier.
Sure.
Different materials, trying to get a little bit more strength out of everything. Right. So it's just ended up being a little bit heavier. Hopefully not too much heavier. I think it's going to be less than 15. And then, but yeah, we're designing the trailers. So we're designing our long trailers to handle a 30,000 pound payload.
Right.
Which ideally could be 2 Casitas or maybe one of the 40-foot units. And all of that still to be towed ideally with a pickup truck, if possible. So.
The one thing we didn't cover on this is unloading these and putting them on piers, putting on foundation, helical piles, tridetics, whatever. They can sit on anything, any foundation system. How do they come off of these trucks and actually get placed? Are we using a 60-ton crane, 100-ton crane? Depends on the reach. And the boom, I get all that. But
yeah, depends on where we're going, what we're doing. We've done cranes, obviously.
Yep.
We've done telehandler forklifts, like a 20K.
Sure.
Yard lift. The way we unload and unload here is with a large forklift that they use for like shipping containers.
Okay.
So we can do all of that. The next generation trailer, we're also working on a system that allows you to lift the unit up, drive the trailer out from underneath, set the unit down on blocks. That's probably not going to work for your like final location.
Yeah.
So you probably still have to move it onto a foundation system.
Sure.
But the most expensive part of any like modular setup, typically, or the most annoying part, is that you have to wait for the crane and the truck to get coordinated with the foundation guys and all that good stuff. Right. So if we can just offload the product, and then the crane and the foundation guys come and they get set up wherever, but our guy is off and he's getting ready to do his next delivery, that's going to save us a lot of time and energy.
And is it if they had to use a crane, would it be a top pick, or is it you're going to hook underneath to lift it?
You hook underneath.
And you run through where the
so we've got locations for where a forklift fork would go.
Yeah.
So you either run straps for a crane underneath there, or you just forklift.
Similar to like a modular, just regular modular lift.
Pretty similar, yeah.
Right.
We do have spaces carved out so they can be dropped onto a flat surface. So you don't have to like cut the straps or do anything weird. Like you can just pull out. Yeah.
Just pulls out. Appreciate it, man.
Yeah, absolutely.
Awesome. I don't know. Is Kyle doing the transportation with us as well? We're getting ready to go outside here. I don't know. They got that weird smile on their face, like something's about to. Oh, you hear a horn? I guess we got to go outside.
Cool.
I don't know. You want to walk with us, Kyle, or you tell us? I don't.
See if.
Let's see what we got. Do we need our hard helmets?
No, I think we'll be okay.
Yeah.
Just grab some water.
You gonna come out?
Yeah.